As soon as humanity began to observe the cosmos, we also began to ask questions regarding our place in the universe. Are we alone? Or could life exist on other planets? Before we proceed, kindly subscribe to our channel and hit the bell button to stay updated when we release new videos. Though we don't have a definite answer for this question yet, recent discoveries by the Kepler telescope might have given us a groundbreaking insight. What type of planets have been observed by the Kepler telescope, and which of these planets can support life? Keep watching to the end. So find out. Kepler was the space telescope designed to survey a portion of the Milky Way galaxy in search of exoplanets, which are planets outside of our solar system. Using data from the Kepler mission and the extended K2 mission, scientists have identified more than 2,800 candidate planets and have confirmed more than 2,600 of these as bona fide exoplanets. A handful of planets are thought to be rocky like Earth, but slightly bigger in orbit in the habitable zone of their stars, or liquid water, an essential ingredient of life as we know it might exist. After 9 years in deep space collecting data that indicate our sky to be filled with billions of hidden planets, more planets even than stars, NASA's Kepler Space Telescope has run out of fuel needed for further science operations. NASA has decided to retire the spacecraft within its current safe orbit away from Earth. Kepler leaves a legacy of more than 2,600 planet discoveries from outside our solar system, many of which could be promising places for life. They are the so-called Earth-like exoplanets. NASA's Kepler mission revolutionized our scientific understanding of our place in the cosmos by a huge amount of discoveries. Before Kepler, we had a little information about exoplanets. For example, how many planets are out there? Which planets are more common? The big gaseous ones, such as Jupiter. The ring giant planets like Saturn. And what about Venus-like planets? Do they exist just in our solar system? And if so, why? All of these were thought-provoking questions that needed to be answered. But the universe is always a little bit more creative than we are. Here's what we know after Kepler. First of all, Kepler has proven that there are more planets and stars in our galaxy. And knowing that revolutionizes our scientific understanding of our place in the cosmos. Kepler has shown that our galaxy is teeming with terrestrial-sized worlds. The most recent analysis of Kepler's discoveries concludes that 20 to 50% of the stars in the sky are likely to have small, possibly rocky planets, similar in size to Earth within the habitable zone of their parent stars. Where water could pool on the planet's surface, we still have much to learn about whether any of them could host life. But Kepler's discovery makes the possibility of alien life way more likely. We've also discovered other solar systems that resemble our own. While our inner solar system has 4 planets, Kepler found systems with considerably more planets, up to 8, orbiting close to their parent stars. The existence of these compact systems raises questions about how solar systems formed. Are these planets born close to their parent star, or do they form farther out and migrate in? Besides launching us into the golden age of exoplanets, Kepler has reinvigorated the study of stars. Kepler observed more than 500,000 stars over the course of its 9 years in operation. As you can see, if there's one thing that Kepler has taught us, that was that there is more out there in the universe, and things are not as alien as we think. That's why we persevere and looking for Earth-like planets that could possibly host life as we know it. Many of the planets we found are hostile places for life as we know it. Some planets are completely made of iron. Others are fireballs brighter than the sun. There are planets bigger than Jupiter orbiting so close to their star, and we don't know how to explain such strange behavior. By Kepler also found Earth-like planets that taste like home planets that would appear to our eyes as very tiny blue dots because they have water and are covered with oceans. And who knows, maybe some of them are currently hosting some sort of life. Earth-sized worlds orbiting in a safe distance from their host stars inside what's known as a habitable zone, or a Goldilocks zone, were detected and studied by Kepler. The Goldilocks zone is where the temperatures are warm enough for water to condense on their surfaces, but not so cold that it will just freeze up entirely. Although being in this zone doesn't guarantee the existence of life, the presence of water is significant for the presence of life as we know it. One such exoplanet discovered by Kepler that has recently generated excitement among researchers is called K2-18b. In September 2019, Two scientific teams independently announced that they found signs of liquid water on the planet's atmosphere situated 124 light-years away from Earth. K2 18b is about 8 times the mass of Earth and 3 times as big. It orbits a main sequence. Red dwarf star called K2 18b. What's a red dwarf star? Well, it's the smallest, coolest star and by far the most common type of star in the Milky Way. According to Kepler data, astronomers estimate that 6% of red dwarf stars have an Earth-sized planet in the Goldilocks zone. This means that life could exist in more places than we currently think. This gives us a huge boost in the research for extraterrestrial life. Who knows, maybe in the next decades, Kepler's successors will finally prove that we are not alone in the universe. We observe the stars that seem optimal candidates to host planetary systems. We study their light and break it down to look for traces of the presence of other worlds. For example, we look at the way the light varies in intensity periodically, due to the trains that have a body that does not emit light in front. The transits technique, or if the star is moving, this is the same transit method that Kepler used to find this is the same transit method that Kepler used to find K2 18b. One such planet is Kepler 1649c. While going through old Kepler data and matching it against new data from the Transiting Exoplanet Survey satellite, also known as TESS, astronomers confirmed the existence of another exoplanet with very favorable conditions for life. Kepler 1649c is located 300 light-years from Earth. It is very similar to Earth in size and estimated temperature. This newly revealed world is only 1.06 times larger than our own planet, and the amount of starlight it receives from its host star, which is also a red dwarf, is 75% of the amount of light Earth receives from our Sun. This means the exoplanet's temperature may be similar to our planet's as well. Kepler 1649c provides yet another example of an Earth-sized planet in the habitable zone of a red dwarf star. Since the Kepler mission was dismissed, one may wonder what's next. Here are a few things we should know about the current mission of studying exoplanets. The Characterizing Exoplanet Satellite, also known as CHEOPS, will be the first mission dedicated to search for transits by means of ultra-high precision photometry on bright stars already known to host planets. By being able to point at nearly any location in the sky, it will provide the unique capability of determining accurate radii for a subset of those planets for which the mass has already been estimated from ground-based spectroscopic surveys. It will also provide precision radii for new planets discovered by the next generation ground-based transit surveys, Neptune size and smaller. Spitzer, designed to observe objects in the infrared spectrum. Spitzer has proven to be a revolutionary tool in the characterization of exoplanets. That mission is the first instrument to directly detect light from an exoplanet, and its data has revealed the composition, temperature, and even likely wind patterns on faraway exoplanets. Spitzer marked a new age in planetary science by being the first telescope to directly detect light of planets outside of our solar system, essentially allowing them to be directly studied and compared. The Great Infrared Observatory also made it possible to determine the temperatures, winds, and atmospheric compositions on these distant planets. Prior to Spitzer, all confirmed exoplanet versions of planets were detected indirectly, mainly by the wobble technique, and more recently, the transit technique, and the first method. A planet is detected by the gravitational tug it exerts on its parent star, which makes the star wobble. In the second plane, its presence is inferred when it passes in front of its star, causing the star to dim or blink. Both strategies use visible white telescopes and indirectly reveal the mass and size of planets respectively. If you enjoyed this video, don't forget to like and subscribe for more content like this.